Hello, and thank you for joining us today. I hope everyone is staying safe and doing well with everything going on. My name is Abdel Jabbar from the Grandstream Support of North America, and I would like to welcome you to our fourth episode of Grandstream Tech Talk. In today's episode, we will talk about the troubleshooting tools available on the Grandstream UCM 6000 and how you can use them to analyze traffic and troubleshoot some of the issues that you might encounter while administering the UCM. So we have selected this topic because we've had many requests from our customers asking us to share the techniques that we use to troubleshoot the cases that we receive. So I will primarily cover the SIP or SIP session initiation protocol and how to troubleshoot related issues. And to do that, I will introduce some basics on how SIP works and explain the SIP methods used to initiate, modify, and terminate call. Then I will introduce Wireshark, which is a very widely used protocol analyzer. I have actually a few captures that we're going to use to show you how to analyze them and how to identify the source of the issue when you run into one. So I will also briefly cover the analog line configuration troubleshooting, and we will wrap up this session with the Q&A. So before I get started, I would like to mention that the recording of this session will be posted on Grandstream YouTube channel by tomorrow. And during this presentation, if you have any questions, please make sure you submit them in the Q&A section. And at the bottom, the Q&A is at the bottom of your screen. And at the end of this presentation, we'll have some time to answer these questions and go over them. All right, so I will start with a quick introduction about SIP or Session Initiation Protocol. As you might know, SIP has become the most common signaling protocol used in the VoIP communications. It is used to establish, modify, and terminate audio and video calls as well. And SIP is a request-response protocol between the user agent client and the user agent server. It basically works similar to HTTP protocol if you are familiar with it. SIP itself is not used to carry the audio or video traffic, but it works in conjunction with other protocols that can achieve that, such as RTP or real-time transport protocol. So SIP in general is getting more and more popular, and most VoIP providers and manufacturers today support it because of the many benefits that it provides, such as mobility, video conferencing, and messaging. And of course, it is cheaper. For instance, a call center that needs, let's say, 100 concurrent calls will need to run 100 analog lines when using POTS lines, or purchase 5 PRI trunks in case of digital. However, with SIP, you can have up to 4,000 concurrent calls on a single gigabit connection. And that's a huge number. And one more thing is that the SIP information is exchanged in plain text. But if you want to add confidentiality to it, you can run SIP over TLS. So the first example that we're going to look at is the SIP registration and how it works between the SIP endpoints or between the user agent client and the user agent server. So when you log into the IP phone for the first time, you enter the SIP account, you save and apply the changes. The IP phone is going to send a register message to the server. And in the SIP register message, the IP phone will include the extension that is trying to register to, and that information is included in the from header and to header. The phone is also going to include in the SIP message its IP address and the port number that's going to be used for SIP. And that's the information that the UCM uses to build the what we call the user location table. Sometimes when you go into the extensions configuration page of the UCM, you see that the UCM actually keeps track of these SIP endpoints by using the IP address and the port number. So the screenshot at the bottom is taken from a SIP registration attempt. So when the IP phone tries to register, the SIP server would always reply back to the IP phone with 401 unauthorized. 401 unauthorized basically does not mean it's a rejection for registration, but the SIP server, they use it to challenge the SIP endpoint for authentication. Sometimes you have 401 unauthorized, sometimes you get 407 proxy authentication required, and you get that message especially when you have an outbound proxy configured on the SIP settings. So in the 401 unauthorized message that the server sends to the IP phone, the server is going to include what we call a nonce. It's a hash, it's a randomly generated number that the server is going to send to the IP phone, asking the IP phone to use that randomly generated number to generate a hash using some information, and one of them is the SIP authentication password. And also it specifies the algorithm that it's going to use for hashing. And most devices, they use MD5 to generate the hash. And so when the phone receives the nonce, it's going to, let me hide this one here so you can see better. So when the phone receives the nonce from the SIP server, it's going to use it together with the SIP password and other information, including the timestamp, and generate a hash and send it to the SIP server. And the SIP server will match the generated hash by the IP phone with the one that is already generated. So if it matches, the registration will be accepted and it will complete successfully. And in the 200 OK, if you notice, there is an expires header. So when the phone registers for the first time, they agree on the time that the phone needs to re-register. So on the Grandstream IP devices, by default, we have 3,600 seconds, which is equal to 1 hour. So when the UCM replies back with the expires of 3,600, that means the IP phone will try to renew the registration midlife. In other words, after 30 minutes, the phone needs to renew the registration. And the UCM is going to keep the registration in the user location table for 1 hour. If the phone does not register for 1 hour, the UCM will just remove that information. Then the IP phone needs to re-register again to renew the registration. The SIP subscribe method is another SIP method and is used by SIP agent clients to let the server know that it needs to receive status information about specific resource. And BLF and Core POC monitoring are examples of SIP subscription. The SIP subscribe message includes the extension or the service that needs to be monitored. And it is similar to the registration process that we just saw, where the SIP server will challenge the user agent's client for authentication before the subscription is accepted for the service. And the status notification is sent in the notify message. So in case you have issues with Core POC not monitoring properly, you can run a trace on the UCM and look for the SIP notify and the subscription notification. The notify message, the subscribe, is also used for the MWI. So when someone calls you and they leave a voicemail for your extension in the UCM will send a message in the SIP notify message to the IP phone to indicate that there is a voicemail for that extension. So this is an example of simple, normal call flow between two UCMs through the telephony switch network. So when Alice makes a phone call to Bob, there are usually these are usually the type of SIP messages that you see in the call flow. And later, when we use Wireshark, I will show you how to display call flows in a similar way. So here I intentionally did not include the call dialogues between the IP phones and the UCM, but it is pretty much similar to the call dialogue between the UCM and the SIP servers. I just didn't want to make it too crowded, so we're going to focus on the traffic between the UCM and the SIP server. So the UCM in Dallas sends an invite to the SIP server that is registered to. And this is how the call gets initiated, by exchanging all these messages between the initiator and the target of the call. So the invite message contains the destination caller ID, source caller ID, and several other information, including the SDP message, which describes the media capabilities supported, as I showed you in the previous slide. And the SIP server will challenge the UCM for authentication with 401 response code. Then the UCM will acknowledge and send a new invite with a hashed authentication response. So when the authentication process completes successfully, the SIP server will respond with 100 trying, which indicates the request has been received successfully and that the server is working on processing the invite. So the invite is forwarded through the telephony switch network, which is in reality more complicated than what we see in this call flow, but we don't care about what happens there. We are only interested in the traffic between the SIP endpoints, which is the UCM, and the SIP servers. So when the invite reaches the IP phone in Boston, it sends 100 trying and 180 ringing. The message 180 ringing is used to alert the IP phone in Dallas to generate local ringback. In other words, when Alice's phone receives 180 ringing, it will play the ringback on the handset locally. In other words, the ringback is generated by Alice's phone. So there is no ringback transmitted by Bob's phone. It's all local. And response code 180 is different than response code 183. Sometimes you will have 183, which is also a very common response code. And this code 183 is used to transmit ringback tone as audio traffic. So sometimes when you run into issues like you make a phone call and you don't hear ringback tone until that person or the remote person picks up the call, that's because you're using 183. And when the remote party sends the ringback tone as voice packets, your firewall most likely blocked them. And the UCM has some options that I will go through, so you can avoid running into these issues with no ringback tone when making our phone calls. So next, when Bob picks up the call, the UCM will forward the 200 OK response to the SIP server. And this response message contains the SDP information with the media capabilities and the connection information that would be used to send audio traffic. And one important thing to note here is that SIP works in tandem with SDP, or Session Description Protocol, which is again used to communicate information about the media negotiation, like the IP address for voice packets, the port number for voice packets, as well as the codec that will be used for audio and video. And I will give you an example. In some cases where you where you have your IP phones, for example, configured to use only one specific codec. And it happens that the remote device does not support the same codec. Let's say, for example, the UCM and the SIP server, both of them are using different codecs. In such a scenario, the case the call will not complete successfully because they have to agree on the codecs that they need to use. And this happens a lot, especially when using the video, when you have two devices from different manufacturers and you have the codecs configured differently. That's what causes the video not to complete successfully because each one is negotiating for a different codec and a different payload in the SDP message. So the 200 OK must be acknowledged with an ACK message, as you can see in the call flow diagram. And if the ACK message is not received within 32 seconds, the call will drop. And this is a very common issue, especially with SIP servers that use multiple servers, like they use one for the SIP traffic, and another one for media traffic, and then they use another proxy for billing. So they want you to send the ACK to a different IP address. And I'm going to go through this in more details in the next slides, and also when we go through the package captures. So at this point, the call is established using SIP, and another protocol will be used to carry voice packets. And this protocol is RTP, which is in orange. And RTP basically means, it stands for real-time transport protocol. And that's the protocol that is used to carry voice packets between SIP endpoints. And in each call leg, there are always two RTP streams, one for each endpoint. So usually when you troubleshoot audio quality issues, you are troubleshooting the RTP traffic, not the SIP traffic. And finally, the call always terminates with a bye message that must be acknowledged with a 200 OK. So we have this call flow diagram as a baseline, and you can use it as a baseline and when troubleshooting SIP-related issues. I have a few more traces that I will share with you during the live demo. So we talked about the SIP methods like invite, subscribe, what else? Web register. So this is a list of, I believe there are 9 of them. The total of them, there are more than 14. So I just picked up the ones that you're going to see more frequently when taking traces on the UCM. So the first method of the first SIP request is the register, and that's the method that the user agent sends to register to the SIP server. The invite method is used to establish a call. It's like when you pick up the handset, you start dialing, it uses the invite message. The cancel will cancel the call before being answered, and the bye terminates the session. So the difference between cancel and bye is like when you go to the dentist. Before you see the dentist, you can cancel the appointment. But once you see the dentist, you only have to tell him bye. There's no way you can cancel the appointment. And the ACK acknowledges the session establishment, as we saw with the 200 OK. And the refer SIP request, that's the one that we use for call transfer. So when you're troubleshooting issues related to transferring calls, the header that you need to look for, or the SIP method that you need to analyze is the refer, because this one includes information about the transfer target, the transferee, the transfer, or the one that initiated the transfer. So you can look at this information and see if there is any mismatch in the information. Subscribe, we already talked about it. When you want to subscribe for notifications like VLF, Call Park, and MWI, the notify is the message that the server will use to notify the user agent client of any changes in the status. The UCM also uses the notify message when using zero config, and this is also a very important one. Zero config, like the Grandstream IP phones or the Grandstream SIP endpoints, the way they work with zero config on the UCM, once they reboot, they send a subscribe message. And in this subscribe message, the SIP endpoint, they include their MAC address and they send it to a multicast IP address. The UCM is always listening to that multicast IP address. And when the UCM finds that there is a configuration template that matches the MAC address in the subscribe message, the UCM is going to send the notify to the phone. And in the notify message, the UCM will include the URL or the TFTP URL or HTTPS or HTTP, depending on which one it's using. It's going to send it to the phone, and the phone is going to use that information to request the config file. And last, we have the options message, which is used to communicate the user agent's capabilities, like what are the supported medias and media capabilities supported, as well as what are the methods supported by the endpoints. And usually you see that very often when you have two UCMs paired together, and when you go to the SIP trunk and the advanced settings, when you enable the keep alive, the UCM is actually sending the options, and the options is used as a keep alive mechanisms to keep status of the reachability of the trunk. So we talked about the request. Now let's look at the response codes. This is I just picked up some of the common response codes that you're going to see more frequently in the traces. There are actually many out there. You can always go to the go to the internet and then look for the SIP response codes. They look similar to the HTTP response codes. So the response codes are divided into 6 categories. The ones that start with 100 are informational about the status. For example, we talked earlier about trying just to tell the user agent client that the request has been received and that the server is working on it. Ringing is to send the message to the IP phone that initiated the call to generate the ringback tone. Session in progress, you send it to tell the IP phone that initiates the call not to generate the local ringback, and that the ringback will come as voice packets so they can play them. Then you have the 200. 200 usually means successful. Like when the call is established, they send 200 OK. There's also 201 accepted. And the redirection, I made a mistake there. It should be 300. That's the 300 range in the redirection. And this one is used when you enable call forwarding or some other mechanisms to forward the call, or when the service is down and you forward the call to another server. So one of them is like the 302. So when you have call forwarding enabled on the IP phone or the UCM, the response code that you need to look for and analyze it is the 302 moved temporarily, where it sends the information about where the call needs to be forwarded. Next, we have the 400 range, which is a request failure, and there are many of these codes out there. And one of them is 41 unauthorized, to ask for authentication. 41 unauthorized can be sent in 2 situations: to ask for authentication and to reject an invalid authentication. Not found is found, like, for example, when you have a UCM with the SIP server sends you the call, then the UCM responds with 404 not found. It could be related to the fact that there is no inbound route configured, or maybe the dial pattern that is configured in the inbound route doesn't match the information that is in the SIP packet. And 486, that's when the phone is busy, like on DND, or the user is actually talking on the phone. That's when the device sends busy here. 500, every time you see 500, just know that it has to do with the server. For example, when you see 501, as a response to one of your messages, that means the server does not accept that kind, or does not support that type of message. And I see a lot of people, for example, when they use the SIP registration with the SIP server, or SIP carrier, they enable the keep alive under the advanced setting of the trunk. And if the SIP server doesn't support the SIP options, it's going to reply back with not implemented. So again, 500 usually means a server failure. And then we have the last category, which is 600 response codes. These are usually generated in such. I'm going to give you some examples. In the UCM, if an extension has a privilege level lower than the privilege level of the outbound route, the UCM is going to respond back to the IP phone with a 600 response code, because that user is not allowed to make call. Sometimes the carrier, they might respond back to you with 600. Let's say, for example, your SIP account only supports national and long distance calls, but when you try to make an international call, your SIP provider will respond back to you with 600 OK to tell you that this service is not supported. Sometimes when your account is low on balance, they're also going to generate 600 message, which is a global failure. So these are the 6 categories of the response codes. When you open the trace with Wireshark, if you remember 100, 200, 300, 400, 500, and 600, that's going to make it way easier for you to understand what you're looking for in the trace. Okay, so now let's look at the header fields inside the SIP message. So every SIP request generated by the user agent must have at least these headers, such as the via header, to header, from header, sequence, number, and the call ID header. So these header, you will see them in all SIP requests. The initial request line includes the, excuse me, includes the SIP method, which is in this case, it's an invite method, together with the destination caller ID and the IP address of the SIP server. You might notice that the SIP URI, or what we call the Uniform Resource Identifier, looks similar to an email. And the from header specifies the caller ID name and number of the user agent client. So when troubleshooting issues related to source caller ID, the from header is where you need to look first. And the caller ID name is usually in quotation marks, and the caller ID number is a part of the SIP URI between the tags. The to header field contains the caller ID of the destination number. So when you have SIP trunks configured on the UCM, the to header is what defines the pattern of your inbound routes. So I'm going to give you an example. So in the to header here, we have a 10-digit number. So when you go to the dial pattern of the inbound route of the UCM, you're just going to put X dot so you can allow all the numbers. However, if your provider sends you a number with a plus then 10 digits, the X dot in the dial pattern of the inbound route is not going to work. Excuse me. And the UCM is going to reject the call with 44 not found, because there is no pattern that matches that one. So in case you have issues with the incoming calls not hitting the UCM or being rejected by the UCM, one of the things that you need to do is run a trace, then look for the call and go to the to header so you can see which pattern is being sent by the SIP provider. So in this case, when you have a number that starts with a plus, you want to go to the dial pattern and add another pattern, which is, for example, plus X dot, so you can allow all the numbers that starts with the plus. So next we have the call ID field, which is used to define a unique dialogue or call. For instance, when the UCM is handling multiple concurrent calls with the SIP server, call ID is one of the fields that the UCM uses to differentiate between active calls. And later when we use Wireshark, you will see how call ID field becomes so helpful to easily distinguish between calls when analyzing the traces. And next we have the sequence number, which is simply used to identify and order transactions within the same dialog. We will look at that too when we open one of these traces. And next we have the contact header field, which contains the SIP URI at which the user agent would like to receive subsequent requests. The contact header plays a major role in issues related to calls dropping after 32 seconds. And later I'm going to show you a trace with the contact header not providing the correct information. And here we have another header, which is the PPI or the P preferred identity. Sometimes you have the PAI or the P asserted identity, depending on which one the phone is using. Some providers, they require that the from header includes the username and the domain name that they provide for you. And if you want to send a different caller ID that is different than the username, they're going to ask you to use the PPI or the P preferred identity or the P asserted identity. So if that is the case, you go to the trunk, and then you configure the PPI with the caller ID that you would like to send to your provider. Not all providers support the PPI and PAI, so this is something that I need to check with the support guys of your provider. And in the invite message, so we talked about this information here, and inside the invite message, the SIP invite message includes the SDP message or the message body. So let me go to the next slide. So the SDP message or session description protocol, this is where the parameters or the media parameters are being negotiated. So if you look at this screenshot here, in the connection information, that's the IP address that this device is requesting to receive voice packets. In some situations, and I'm going to show you this later, the SIP servers, they use different servers for load balancing and for different purposes. In some cases, they have a media server and then they have the SIP server. So they want SIP to go through a server, but the media, they want you to send it to a different server. In that case, they're going to include a different IP address than the one that is being used in the SIP messages. And yeah, let me explain that later with more details in the next slide, because I have some other information to share with you. And the in the media description, it also includes the RTP port. So in this case, the RTP port for audio is 5004. If you have a video phone, you're going to have another one here at the bottom for video. So you would know which port is being used for audio and which port is being used for video. And this is the list of supported codecs. It includes PCMU, PCMA, G723, G729, G722, ILDC, and G726. So when the endpoint or when the UCM and the SIP server tries to negotiate which codec they're going to use, they're always going to start with the first one. If the server supports PCMU, then they're going to go for PCMU. So if you want to change the order, you can always go to the UCM and change the order. So in case, for example, you want to use G722, which provides a better audio quality than the PCMU, you can prioritize the G722 and put it on top of the list. So whatever you choose under the advanced settings of the SIP trunk, the order of the codec, that's the order that's going to be displayed here. And in the SDP message, they also include the DTMF method that they need to negotiate. There are usually three methods. There is the in audio, like the analog lines, and there is the RTP event, and there is the SIP info. The one that is most commonly used is the RTP event, which is the telephone event in this case, and it also uses the payload 101. This can become an issue when using devices from different vendors. Because different vendors, they use different payloads and they use different DTMF methods. One example is when you use a door system with the UCM, and you connect, everything is registered, everything is working fine. However, when you call and you try to enter the PIN number to unlock a door, it doesn't work. That is most likely related to a mismatch in the DTMF method used, or a mismatch in the DTMF payload. And the UCM gives you the option to change these parameters so you can prioritize which one you want to use. All right, let's move next. This is an example that I talked about earlier with the connection information, the IP address that is used for voice packets. We have two examples here from two different servers. The one to the left, as you can see, the provider is using multiple SIP proxies. Is using one for SIP proxy to handle only SIP packets. But when it comes to voice packets, it has another media proxy. And in the SIP information, in the connection information that I showed you earlier, that's where the SIP provider will send or will include the IP address of the media proxy, so you can send all the voice packets to that proxy. On the right, this is a very common scenario. A lot of SIP servers who don't have like sophisticated infrastructure, or they don't have large volume of calls, they only use one server for both SIP and media. And that's the easy one. So when you have provider with that setting right here to the right, you're not going to run a lot into issues related to audio. All right, so let's talk now about NAT settings on the UCM, and how these IP addresses makes a difference. Like when you go to the SIP trunk and you have the NAT setting, you check it and check it. So what difference does it make when you toggle these settings? So before we talk about the UCM settings, so let's look at this IP package, which includes session initiation protocol message inside it. So at the top, we have the IP address. This is the source IP address of the IP packet. Then next, we have the contact header, which is included in the SIP message. And then we have the connection information IP address, which is included in the SDP message. So here we have three IP addresses. And so you might be wondering which one should I use? What is the purpose of this one? What is the purpose of that one? So let's look at them. So the top one, which is the source IP address of the IP packet. When you go to the UCM under the SIP trunk and you have the NAT setting checked, the UCM is going to ignore the information right here in the contact header. It's going to ignore that information. It's not going to use it. However, when you uncheck the NAT setting in the SIP trunk, the UCM is not going to use this information for subsequent requests, but it's going to use the IP address and the port number in the contact header. And this is used especially in most cases, it's the same IP address, but there are cases where the source IP address is different than the one in the contact header. One example, when you have remote phones sitting behind a router in a private network, the phones have no way of knowing what is their public IP, so they're always going to include their private IP address in the contact header. And the UCM also has another setting for remote extensions that I'm going to show you later when we play with one of the traces. The second scenario where these two can be different when you have provider that uses multiple proxies, as I showed you, and probably it uses one for SIP and another one for billing, then another one for media proxy. So if that's the case, for billing, it's going to include a different IP address here. So that the UCM, when it receives the 200 OK, it needs to send the acknowledgement to the IP address in the contact header, and that is most likely the IP address of the billing server. And that is why sometimes this setting can cause the calls to drop after 32 seconds. Like you initiate the call, you have two-way audio, no problem. But after the 32 seconds, the call drops. The reason why, because the provider is expecting you or expecting the UCM to send the ACK of 200 OK to the IP address in the contact header. So every time you run into a similar issue, like the call gets initiated, but after 32 seconds it drops, most likely it has to do with the contact header. So what you need to do, go to the SIP trunk and toggle the NAT setting. So that's the setting that you need to change. And the last one, which is the connection information. So when you go to the UCM and the PBX settings, SIP settings, NAT, and you enter your public IP address and you select your local network, this is the information that the UCM will use in the connection information. So most likely when you have remote phones and the UCM is not configured with a public IP address, you run into issues like no-way audio or one-way audio. So that's the purpose of making that change in the external host so that the UCM can include that information in the connection information and in the contact information. Another mechanism that we use, especially on remote phones that are trying to register to UCM, let's say in the headquarters, is that the phones they register, and however, when you make a phone call, you experience one-way audio issues. Either the remote party can't hear you or you can't hear them. So that's related to the information that I previously explained right here, because the phones have no way of knowing what is their public IP address unless you implement some of these protocols. And one of them is the stun server. The stun server works in this way. So when you go to the IP phone and you enable stun server, I'm going to show you later how you enable that on the IP phone. The IP phone will be configured with the stun server. The phone is going to send stun message to the stun server that it's going to ask him, what is my public IP address? Then the stun server will send some messages to detect the public IP address and send it to the IP phone. When the IP phone receives the public IP address, that's the one that it's going to use in the contact header, for example, and in the connection information. So it's going to change these IP addresses in the SIP packet from private IP address to a public IP address that the stun server provided to the IP phone. So again, if you have IP phones configured remotely and you run into one-way audio issue or no-way audio issue, like no audio at all, one of the things that you can use is enable stun on the IP phone. Another important thing about stun is that it doesn't work with symmetrical NATing. So if you have a router with the symmetrical NATing, it's not going to work. So you're probably going to have to go to the router and disable the symmetrical NATing and use different types of NATing. All right, so that brings us to Wireshark. Wireshark is a free application that you can download for free if you go to wireshark.org. It's a very useful application that we use to analyze all the packets. All the Grandstream devices have built-in packet capture. You just download them and then you read them with Wireshark. And with Wireshark, you can do so many things. With regards to VoIP, you can use it to play the RTP packets. Like if you capture packets using specific codec like G722, you can actually have access to the voice packets and play them again. You also have access to statistics about the call. In case you run into jitter issues, you can use Wireshark to analyze jitter and see what is the source of the jitter. And we're going to go through this when I have a few slides that I took that we're going to play with. And you can also use it to detect any malicious packets, like someone who is trying to register to UCM or someone who is trying to make calls out of UCM. So with packets capture, it helps you a lot identify the issues. All right, so let's close this one. So now let's talk about how you can take traces from the UCM. So when you run into an issue, let's say incoming calls are not hearing the UCM, or one-way audio issues, or any kind of issues related to SIP or network. You go to maintenance, network, troubleshooting, and then you choose, usually it's the LAN, but if you have the UCM in a route mode, you're going to have LAN and WAN. So in that case, you need to decide where you suspect the problem is. Is it on the server side or is it in the IP phone? You can run two traces and then analyze them and decide what the source of the issue is. It is the source. It is the LAN or the WAN. So when you take traces, you just enable the LAN and then you start the trace, replicate the issue, and then when you're done, you just download the trace. And when you download it, the UCM usually downloads it in a tar file. So you're going to have to unzip it and get the PCAP file and then open it with Wireshark. On the IP phones is similar. So you just go to maintenance, packet capture, and start the trace. If you have issues related to audio, you want to check RTP and set that one to yes. Then start the capture, make the test call, replicate the issue. When you're done, download it and attach it to the ticket. If you don't know how to analyze it, or if you know how to analyze it, you can just open it with Wireshark and start looking for the things that might interest you. So I have a few traces here. Let me close this one. So I have 6 traces, and these traces, they usually summarize the most common issues encountered on the UCM. So the first trace will have issue regarding one-way audio on remote phones. So let me open this one. So when you open the trace usually has information that is SIP related and other information that has to do with the TCP or other traffic in your network. Usually to analyze phone calls like dialogues, I go to telephony, and then you look for VoIP calls. And then here it displays all the VoIP calls that were made while you were running the trace. So let's say I'm looking for the second one. You select, and then you have some options here. In case you want to remove all the packets, but you just want to display packets related to this call, you can use prepare filter. Then all the junk here will go away, and only the packets, the SIP packets related to this call will be displayed on the packet capture. If you want to play the stream, you can use the replay, and then you can use this button to play the stream. So in case someone is complaining about audio quality issues and you want to hear it, so you can define what kind of audio issue. Is it echo? Is it jitter? Is it buzzing noise? Is it static? So you can use the play stream to play the audio. So now let's look at the flow sequence, which is going to give us a diagram similar to the one that we saw earlier. So I'm just going to close this one and open it again, because I see some duplicate packets there. So I will select this one, flow sequence. So when you click on flow sequence, it's going to give you information about the call. Let me try again one more time, so because earlier I mentioned the call ID. So when I select both calls, you will see that Wireshark displays them in different colors, green and orange. So the way Wireshark knows which color to use is based on the call ID that I showed you earlier, which defines the dialogue or the call. So I'm only interested in the second one. So if you look right here, let me try to minimize this one so we can have access to the packets. Let me expand. So this is the SIP message, and at the bottom you have the SDP or the description message. So I'll go back here. The one thing that you're going to notice here, every time you see multiple messages going in the same direction, that's always an indication that something is wrong here. And we're going to see what is wrong here. So if you look at the invite, and this invite is from a remote phone, I believe. sent to the UCM. So this phone is actually has the IP address 172.16.0.54, and it's located behind this router right here. So when this device sends an invite, it's going to include its private IP address, as I mentioned, because it has no way of knowing the public IP address because it's not using stun or UPnP or other mechanisms that they use to detect the public IP. Then the device again is going to send that message. And then if you look right here, in the connection information, it has the private IP address of the phone. The contact header has the private IP of the phone, the remote phone. So the UCM is going to reply back with 200 OK, then the ACK here. However, here, by the way, there is no audio because all the information is messed up. So the UCM is actually sending audio. If we look right here at the RTP, let me scroll down so you can see it. Not this one. So here there is no RTP because all the packets are messed up. But one thing that you're going to notice here about the buy is that the UCM is actually sending the buy to the private IP address of the phone, which is 172.16.0.54. And because this is a private IP address and it does not exist in the local network, these packets are not being routed to their destination. Because in this case, the UCM is supposed to send the buy to this IP address, which is the public or the WAN IP address of the router. And the reason why the UCM is using that, sending the buy to the private IP address, could be related to two things. One of them, and most likely the extension, let me show you here. If you go to the extension, let's select this one, for example. If you go to under media, there is this NAT setting right here. By default, this is checked. Sometimes people, when they run into issues, they start unchecking, check and see which one is going to fix their problem. And sometimes they uncheck things and leave them unchecked. So in the trace that we just saw, let me get the call flow again here. The UCM is sending the buy to the private IP address inside the SIP message because this NAT is unchecked. And once you check it, the UCM is going to ignore the information inside the SIP message and use the IP address, the source IP address in the IP packet. So this is one way to solve the issue. And this is the first thing that you need to look at. The second thing, if this one is checked and you still run into issues, you can enable stun on the IP phones. And to enable stun is very straightforward. You go to general settings and you define the stun server that you would like to use. So I usually use the Grandstream IP Video Talk stun server, which is stun.ipvideotalk.com. So I define the stun server, then I go to the IP phone, to the account, I mean, and you go under network settings, and the NAT traversal, you change it to stun, save, and apply. So when you enable that, the UCM, the IP phone, I'm sorry, is going to query the stun server about its public IP address, and in the SIP information messages, all these private IP addresses, and go back here one more time. This IP address or private IP address will be changed with the public or the WAN IP address of the router. This together with the connection information that's going to be used for voice packets. So we talked about the call flow, how you can display it, so you can look for problems. Visually, it makes it way easier to detect what the problem is. As I mentioned earlier, when you see multiple messages of the same method sent multiple times, that's usually an indication of a problem in the NAT settings. In case you are only interested in troubleshooting SIP packets, there are some filters that you can use with Wireshark. You can use, for example, SIP. If you're only interested, let's say, in this call, let me go back here. If I select this one, then I choose this, this dialog. And if you have multiple SIP packets and it's too much for you, it's like you just want to display the packets related to that call, you can always go to the call ID, right click on it, and apply as a filter, select. So when you do that, the UCM is going to display, the Wireshark is going to display only the packets related to that call. So let's close this one. Let's look at another trace. Let's look at the stun. So again, here we have a lot of packets. So I'm just going to filter by stun packets. So this is an example of how stun works. The IP phone is going to send a stun request to the stun server, and it's going to use the source IP and the port number. Then the stun server will reply back to the IP phone with its public IP address. For example, this device right here, its public IP address is 209.6.181.137. Then that's how the IP phone will use this information to include it in its SIP message. Let's look at this example also where calls are getting disconnected after 32 seconds. So again, we're going to go to telephony, avoid calls, and then we're going to select the call flow. So if you notice right here, let me remove this one. Put this one here. Let's expand this one. So in this example that we have here, the phone is in the local network together with the UCM. Both of them are in the same subnet. However, when the phone here sends the 200 OK because the remote party picked up the call, the UCM sends 200 OK to the IP phone. However, the IP phone is not sending the ACK. We don't see the ACK. And the UCM, because it's expecting to receive the ACK or the acknowledgement, it's going to try and try and try again for 32 seconds. If there is no response from the IP phone, the UCM will drop the call after 32 seconds with a bye message. And this is, if you look at this, it looks like weird. I mean, where is the ACK? If you go to the IP phone and take the trace from the IP phone, you will notice that the IP phone is actually sending the ACK to the UCM, but it's sending it to a different IP address because the UCM here is using a public IP address, which is 50.227.212.1. So in the contact header, that's why the contact header is very important because that's the IP address that is used for ACK and bye method. So if the information that is communicated to the SIP endpoint is incorrect, you will end up with issues similar to this. So now you might be wondering, so what is causing this issue? So let's go to this UCM and see what is causing that problem. So this is the UCM with the issue. I usually would go to PBX, SIP settings, NAT settings. And you can see that the UCM actually has a public IP address. But if you look at the local network, you will see that it's using a different subnet. And the trace here, if you look at it, the subnet should be 172.16.0.0. So the configuration here is wrong. The public IP address could be right, but the local network is wrong. So when you configure it this way, the UCM will think that the subnet 172.16.0.0 is not a local network. So when it's not a local network, the UCM is supposed to send its public IP address. And the ones that you include under the local network, these are the ones that the UCM is not going to use the net. In other words, it's not going to respond with the public IP address. It's always going to respond with the private IP address. So to solve this issue, you just need to add the local subnet, add, save, and apply the changes and reboot the UCM because these changes requires rebooting the UCM. So I'm going to stay here with this trace. Let me see if there's any RTP traffic here. Maybe I can check down in the next traces. So we check that one between internal extension and the UCM. So this is another example between a UCM and the SIP provider. So let's look at this trace right here. So in this trace, we have the same thing. But here the provider is actually receiving the ACK. But why is the call not being sent, not being continued? Because here you will see that the provider will send to end, okay, the UCM will reply, here is the ACK. Then it's going to ask again, I need the ACK, then the UCM will sense it again. And it's going to keep trying and trying. After 30 seconds, 32 seconds, it's going to disconnect the call. So the reason why this happens on the SIP trunk, because the NAT setting is either checked or unchecked. But in our scenario, the NAT setting is checked and it should not be checked. And let's look at the this is the packets. So here when the SIP server sends the 200 OK, look at the contact header. The contact header has a different IP address than this one. So it's asking the UCM to send the ACK to this IP address. But the UCM is actually sending the ACK to the same IP address. And that's what happens when you have the NAT setting on the SIP trunk checked, because you tell the UCM to always respond to the source IP address. However, when you uncheck the NAT setting in the SIP trunk, the UCM then will read the contact header and send the ACK back to that IP address. So to fix that issue again, let me go to the web UI here. And we want work trunks. So to fix that issue, you need to go to the UCM and uncheck this option. If you have it checked, you're going to experience the same issue. So to get rid of that issue, you have to uncheck the NAT setting so that the UCM can reply back to the IP address in the SIP message. So let me close this one here. Now let's look at the SIP registration message. So here, let's look at this trace. This is a SIP registration message. So we're just going to look at the message itself. The phone is sending SIP register to the server. The server, again, is going to challenge the IP phone to use the nonce, randomly generated code to generate the hash. Then the IP phone will use the nonce and generate a hash and send it as a response to the server. Then here you will notice that the server, even if the authentication is correct, the server here is sending a message that says 423 interval to brief. This is usually a case where someone is trying to register too frequently to the SIP server, they get that message interval to brief. Because if you look at the last one here, the expire means 1 minute and 29 seconds. And the UCM, the minimum value that is using is 90 seconds. So anything that is 90 seconds, or anyone that is trying to register with an expire field of lower than 90, the UCM will reject that registration with 423 interval to brief. Then the phone again will try to register, but this time is going to use 90, and that's where the binding is complete successfully. So let me show you where that setting actually is implemented on the UCM. If you go to PBX settings, SIP settings, TOS, this is where you define those timeouts. So as you can see here, the minimum registration on subscription time is 90 seconds. I don't recommend changing that one, but if you have third-party devices being used with the UCM and you don't know where to change it from the other devices, you can always come here and change it, for example, to 80. The maximum is 36. So this is the maximum and this is the minimum, so you can solve that issue with interval to breathe. This is a very common issue when people use third-party devices with the UCM, and they say that their devices, they lose registration and then they re-register again, lose registration and re-register again. That could be one of these issues. So now I'm going to use the last trace here so I can show you how you can analyze jitter on the, let me hide this one. How you can analyze jitter on a trace. So let's say your client, they call you and they tell you that the audio is choppy and you are using SIP trunks, so you want to know whether it's network congestion or if it's static or things like that. So first of all, I'm going to filter this trace with RTP. So I'm only interested in RTP, which is the voice packets. So I'm going to choose one of these. Then I'm going to use, no, I'm sorry. Choose the RTP, go to telephony, and then go to RTP, and then stream analysis. So when you do the stream analysis, you will get this page. This page will give you information about each packet. It's like this packet right here had a jitter of 0.03 millisecond. And this one here has, for example, 0.04 milliseconds. So this is forward is in one direction, which means from this IP 1.20 to this IP. And the reverse is from 209.6.181.137 back to 192.168.1.20. And here on the side, this is where you have the summary of these packets. For example, let's look at the forward one. So if you look at the forward one, you will see that the maximum jitter was 0.65 and the mean jitter is 0.05. This is very good. That means the audio quality going from the UCM to the remote party has no jitter whatsoever. You will start noticing issues with the audio quality when the jitter reaches 20 milliseconds. And you will start noticing that words are dropping when it reaches 30 milliseconds. So as long as it is below 20 milliseconds, it's good because you can always the audio quality is always good. However, if we look at the reverse traffic, which is from the remote device back to the UCM, the numbers are different. The maximum jitter here at one point reaches 65 milliseconds. And I'm pretty sure during that time, the receiving party did not hear or missed some words. And the mean jitter here is 6.30, which is still good. It's not bad. And it also gives you information about the packets lost. So this device was expected to receive 1,336 packets, but it only received 1,314. And the reason it knows that, because each RTP packet has a number, has a sequence number, and that's how it determines that it missed some calls. So the lost packet here is 22 packets with the percentage of 1.67. And if you want to display that one in a graph, let me remove that stuff here. So we can only look at the jitter. You will notice that the reverse jitter is high, and one point, that's the point where it reaches 65.18. So that's just one way of how you can analyze jitter to determine if your network has jitter problems, or if the audio is or the choppiness in the audio is actually originating from somewhere else. And this happens a lot. It's like your traffic is good. However, when you receive it on the WAN side of your network, the audio is already choppy, probably because there's congestion on the WAN side and not on the LAN side. But this one is going to help you identify problems on the LAN side. So I'm going to stop here for a moment to look at the at some of these questions. Baba Tundi is asking, can we have this presentation recording after the session? The recording will be available after this presentation. We're going to post the video on the Grandstream YouTube channel. Hopefully we can do it today. If not, most likely by tomorrow. So Keith is explaining, can you explain the difference between route, dual, and switch mode on the UCM? So that's on a different topic, but I can address it quickly here. So when you go to network settings, you have three modes. Switch mode, because the UCM has, you use it in switch mode. In other words, it's just going to work as a switch port, like SIP endpoint device, like any other device in your network. It's not going to generate IP addresses, but it's just going to work like an endpoint, like a host in your network. Routes, I would use route in case I have IP phones sitting behind the UCM, and I want the IP phones to route all the traffic through the UCM. But I would not use the UCM as the route for the whole network, because I want the UCM, the resources of the UCM, to be focused on call routing and not traffic routing of the other devices. Dual mode is when you have two separate gateways. I'm going to give you an example. Sometimes with certain providers, they bring that device to you as a gateway. They tell you this is going to be your voice gateway. Okay, so all the SIP and RTP traffic needs to go through that gateway. However, if you try to send an email, like email to voicemail or the UCM through that gateway, it's not going to work. So you need to use another gateway. And that's when we use dual mode. It's like one network with two gateways. So you specify here the gateways, like in LAN 1 and LAN 2, and you make sure you correct them correctly. So each one goes to its place. Then you specify which is going to be the default interface. In my experience, I usually use the one that's going to be used for the data. I use it as the default interface. Okay, so all the traffic goes through the main router. And then I go here in the static route and I create static route. For example, if the voice gateway has this IP, so this is just, I'm going to assume this is the IP. I'm going to include that IP and then include the gateway or the IP address of the gateway. So only traffic for the provider will go through this interface. And I hope that explains that answers your question. Shame is asking, does the packet capture also work with SIP encrypted SIP? So when you try to capture the encrypted SIP with the Wireshark, you can always do that, but the problem with the traffic is going to be encrypted. So you need to have access to the certificate keys, and Wireshark has some options that allow you to decrypt traffic in case you have a private key. This is a long presentation about Wireshark, how to decrypt traffic using Wireshark, but it is possible as long as you have access to the keys that were used in the HTTPS encryption. Can I use multiple UCM, one as a SIP proxy and other as a media proxy? No, no, this is not possible. The UCM does not support these capabilities. This is usually supported in the switches that are used by the providers and some other expensive devices. These are the ones that have this option. You can use one for media and use the other one for SIP signaling, but the UCM does not support this option because you need to use what we call the cluster. And when you put all the servers in the cluster, they synchronize with each other. And the UCM currently doesn't have any mechanisms for cluster synchronization. John is asking, typically when you have multiple SIP devices behind NAT, router, ALG, it needs to be turned off. Otherwise, it creates loads of problems. Even with ALG turned off, I see issues with phones staying up and able to ring when invite is sent to them. NAT is turned on for the extensions to stun or keep alive the options behind. John, I think you're right. SIP ALG does more damage than it does to solve problems. And when you have the, let me show you something here. Let me just remove that one. So when you have remote phones, one of the things that you probably can do is go to the IP phone. Because usually when you have issues with like phones, they register at the beginning. You can call out, but at a certain time you can't receive calls. That could be related to you. That's most likely related to your router. Why, when the UCM, when the IP phone, I'm sorry, when the IP phone sends the SIP registration to the SIP server, as we saw in the presentation, the phone will need to wait 30 minutes before it tries to re-register again. And these values, you can change them right here. If you go to SIP settings, basic settings. So the register expiration is 60 minutes. So the IP phone will try to register to the UCM after 30 minutes. If your router doesn't keep the NAT table for more than 30 minutes, let's say after 15 minutes, it just cleans the NAT table and it starts again. So when you send the call from the UCM to the IP phone, the local router where the IP phone is located is going to reject the call because there's no port open for that IP address. And one of the things that I would recommend here is you can reduce the register expiration timeout to 5 minutes so that the phone will try to register every 2.5 minutes. And this way it's going to keep or keep the port on the NAT table open. This is one. The other that you can do, I believe it's enabled by default, which is the keep alive. Keep alive, basically, when you enable it as NAT traversal, the IP phone is going to start sending UDP, empty UDP packets every 60 seconds, I believe. And this helps the router keep that port open. Let me go up a little bit here to see what the question is. The dot is asked how many RTP ports are needed for per extensions because the RTP port range is too high. Let me give you a trick about the RTP on the UCMs. So if you go to PBX settings, RTP settings, this is the range that is being used by the UCM. And by the way, this range is the local ports of the UCM. In other words, these are the RTP ports that the remote devices or the internal devices need to reach the UCM. In most cases, I'm not saying in all the cases, in most cases, you don't need to open these ports on the firewall. All you need to do is go to SIP settings, PBX settings, I'm sorry, SIP settings, and TOS, and try to set this one to 1, RTP keep alive. And what this one does, when the remote party sends the invite message or the 200 OK with the connection information, like the port number that's going to be used for RTP or voice traffic, the UCM is going to read that information, and after 1 second, it's going to send an RTP packet out of that port. And when the RTP packet is sent from inside the network through the router will automatically open that port. This is how UDP works in most cases. Like when you go to the to a website, for example, and you go to Facebook, once you launch it from inside, it becomes an established connection. So the router will keep that connection open. So for you, again, you don't have to open ports 10,000 to 20,000. You can simply use this option so that the UCM can send packets. Let me just use this one. So you can simply use that one so that the UCM can punch holes into your router. Mohammed is asking, is RTP capture only available on the phone or also on the UCM? If not available on the UCM, what happens when you enable direct media? So the UCM has it by default. And the reason we include this option of RTP, let me go back here so you can understand why. Because the memory size of the IP phone is smaller than the memory size of the UCM. So that's why the UCM is enabled by default. But in case you are trying to capture an issue, let's say you're trying to capture a subscription for BLF for Call Park, you don't need the RTP because we're not talking about audio, we're talking about subscription. So because the amount of or the size of memory on the IP phone is limited, we give the option to disable RTP so that the IP phone can only capture the other traffic. So that's the reason why, but both of them are available on the IP phone and the UCM. I think there was another question that you asked. Yeah, and you also talked about enable direct media. Let me go back here. So extensions. So I believe you're talking about this one, the media, direct media. So this one by default, it's disabled. When you enable it, basically you tell the UCM if phone A calls phone B and both of them are registered to the UCM, in the connection information, the UCM is going to send the IP address of each endpoint. So when the SIP session is established, the two phones, the media between the two phones will be sent directly to each other, not through the UCM. This is a good thing to implement, but it has some drawbacks. And one of them is that if you have call recording enabled on the UCM, it's not going to work because the audio doesn't go through the UCM. It goes directly between SIP endpoints. So this is it has some advantages and it also has some disadvantages. Mike Bola is saying in system events, I always see my GXP re-registering. Why is this? One of the things, Mike, that I can suggest for you to try is if you go to SIP settings, basic settings, try to toggle these options right here. So, for example, unregister and reboot, you can set it to all, to no, or instance. This is also a very common issue that I noticed a long time ago. That was like an old case that I had a long time ago, is that certain devices, when they reboot, they remove the registration, then they try to re-register again. And if that issue still exists, I would like to see the trace and see exactly what might be causing that problem. Mahara is asking separate questions. How can we increase the number of paging groups? Unfortunately, there's no way you can increase them. Based on your UCM models, the number of devices that are supporting my paging group, you cannot increase it. Probably, I believe that with the new UCM that we're going to release in a month, in a few months, probably in a month or less, that one will have more hardware capacity that's going to allow you to add more paging groups compared to the 6200. And Jack Martin is asking a question. We have customer where if they are dialed into an audio conference and there is no audio activity within 130 seconds, the endpoints are disconnected. Is there setting in the SIP settings that can be adjusted? This could be a different issue, Jack. I would like to see a capture of that one. You can reproduce it again, go to the UCM, start the capture, replicate the issue, and you can send it to my email, the one that you're going to see in the thank you email notification at the end of this presentation. C Dot is asking, is it possible to configure UCM through GDM. No, this is not support. The only thing that you can do with GDMS is you can sync the let me go back here so I can show you. The only thing that you can do is you can sync the contacts of the UCM, so you can sync them with your GDMS account. So all the extensions that you created here, so when you sync it using the GDMS settings, you can sync it with your account, so you can have all the extensions uploaded to your GDMS account. Grant is asking, is there an example when call forwarding from extension to external has not worked? I'm not sure what you mean by has not worked, but if you have audio issues, again, you might want to need to use this option here and the TOS RTP keep alive, set that one to 1. This feature, again, is very useful in this scenario when you have calls coming in and you have the UCM configured to forward the call to an external number. Using the default settings and without opening the RTP port, like doing port forwarding on the router, you're going to end up with no way audio. It's like there's no audio in the call. So to overcome this issue with the forwarding calls to external numbers, go to the UCM and the SIP settings, TOS, and set the RTP keep alive to 1. Again, if you guys have any questions, just please remember to submit them in the Q&A section, because I usually don't look into the chat area. So we still have some time, so I'm just going to go quickly through the analog trunks and how you can troubleshoot them and configure them. This is going to be a brief one. I'm going to log into one of the UCMs that has some analog lines. Let's check right here. So we have one FXO port configured or connected. So to add the analog trunks on the UCM, let me delete that one so we can add it again. So you just click on add analog trunk, and I have 2 channels, so I can select both of them, or you can choose one of them. You just assign it a name. I can call it, for example, trunk. The SLA, there is another webinar about SLA, but we're not going to talk about it in this presentation. SLA basically stands for shared line appearance when you try to use the UCM as a key system to allow users to monitor the status of the analog lines. Then next, there is the polarity reversal. Polarity reversal is used for 2 purposes. One of them is for call supervision. In other words, once you make an outbound call and the remote party receives the signal about that call, the counter is going to start on the UCM. So the call is going to be considered as answered. The second one is polarity reversal in some countries is used as a disconnect signaling mechanisms to disconnect the call. And one of the cases where you don't want to enable polarity reversal is when you have rings simultaneously at the extension level. And the kind of issue you're going to experience is when the call comes in, it's going to ring the local extension and the remote or the external number. The local extension is going to ring for a fraction of a second, probably a second or less. Then the call will go to the external device. So if you have any issues like this, like the local extension with the simultaneously ring feature enabled, you want to come back here and toggle the polarity reversal option. The disconnect or the current disconnect is the mechanism used to detect whether the circuit is open or closed. And you can specify the threshold. If you don't have these tools to measure the threshold, you can simply use the detect PSTN option that is available under the trunk. It's very simple. You just detect. I usually use semi-auto detect. I choose the channel that I would like to detect, and then I enter cell phone number and detect. Once you do that, the UCM is going to call the cell phone number. Then it's going to display 3 other steps that you need to follow so that the UCM can detect the line parameters and apply them to the FXO ports. The RX and TX gain, I would recommend to leave them the way they are unless you have issues, because if you increase the TX, you're going to end up with issues like echo. So if the volume is low, let's say for the reception, like the volume is low on the analog lines, you can increase that one probably to 6. But if you increase it to a higher level, let's say these are the values supported. Let's say to 12. If it's too high, it's going to start generating echo on the lines. So be careful with these settings, or you probably want to try different values and test. Use caller ID by default is checked. In some cases, use caller ID can give you a hard time, especially when the POTS lines do not carry the caller ID in the call. So when you have the use caller ID checked, the UCM is going to wait for the caller ID before it sends the call to the user. And these are the caller ID schemes. In the United States, we use Belcore, and I believe in Canada as well. Then we have the FXO dial delay in milliseconds. This is the case where you need to change this one. If your client tells you that when they dial a 10-digit number, the provider only receives 8 of them or 9 or only 5 of them, that could be related to the FXO dial delay. So if you ever experience an issue where the UCM does not, or the carrier does not receive all the digits, you might want to increase that one to 500 milliseconds. Then save and apply. Again, you can use the detect tool, and it's going to help you detect all these parameters in case you don't know what is the threshold. You don't have the tool to analyze that. So we're just going to save and apply. Another option that you can use to adjust the parameters of the line is use the FXO ASIM detection. So the ASIM detection is used to detect the voltage of the line. It's also very straightforward. You don't need to enter any value. You just come here and you detect the ASIM or the AC impedance of these lines, and the UCM will detect them automatically. And once the detection is done, you just click on update so that you can apply them to the lines. So the lines are straightforward. There's not much that you have to excuse me, you have to toggle or change. However, in case you run into issues with analog lines, the UCM has the option with the analog record trace. So if you are experiencing issues in FXO1, you can select the FXO1, start the trace, then make a call. And when you're done with the call, then you can stop the trace, download it, and you can send it to the Grandstream support to analyze it for you, because they include some proprietary acronyms that probably you're not going to understand. But if you're able to get something from the trace, that's good. If not, just open a ticket and attach it to Grandstream support. Another troubleshooting tool that's available on the UCM is syslog. Syslog we usually recommend it when there are problems with the system itself or problems with the hardware. That's where we recommend implementing syslog. If your UCM is working fine, there are no issues, I don't see a reason why you have to enable syslog. Because every time you enable syslog, it generates a lot of traffic in the UCM, which takes a lot of resources, and it also generates more traffic in your network, which takes a lot of bandwidth. So to troubleshoot issues, depending on what issue you're looking at. So first of all, you just enter the IP address. You can enter any IP. I can just include this one, for example, or you can include the IP address of your gateway. So if you have issues with the analog trunks, one of the things I need to check is the channel DHDI. So this one, make sure you set all these levels to yes, save and apply, And the way you're going to capture syslog is you go back to network troubleshooting and you start the trace. So if you're using LAN or WAN, just start the trace, then the UCM will automatically capture all the syslog packets that the UCM sends. If you're able to read them, that's great. If not, you can attach them to a ticket and send them to a Grandstream so an engineer can look at them. All right, let's see more questions here in the Q&A section. David is asking, do I need to reboot the UCM after ACM detection? This is being advocated in the GS. I mean, honestly, this is not required. It is not required to reboot the UCM after detection. Sometimes rebooting helps solve a lot of issues. If that solves the issue, that's even great. Just detect the parameters and then reboot the UCM. But based on the documentation of Grandstream, you don't have to do that. And I solved a lot of cases just with ASIM detection without rebooting the UCM. But rebooting the UCM again is not going to hurt if you do it. I'm going to go quickly and check a few more questions here. You can bear with me 1 second. So I think I covered all the questions. And again, thanks everyone for joining us in this session of Tech Talk. I really appreciate your time with us. And I hope you guys stay safe and do well with whatever is going on right now in the world. And we'll see you next time in one of the webinars.